Today we're going to take a look at measures of variation. So the whole purpose of measures of variation is to help us paint a more complete picture about what a data set is telling us, other than just looking at sectors alone. There are three measures of variation. They are range, standard deviation, and variance. However, variance we're not going to use in this particular class because the units don't really match up with the data value. So say you were talking about the number of people that have done something, variance would be measured in square people or people squared, which doesn't really make any sense. It gets used a lot in more theoretical statistics, but we're in statistical methods or applied statistics. So we're going to stay away from variance, other than just to introduce what it is. We're going to talk a lot about range and standard deviation today. Okay, so what is the range? Range tells you the span of a data set, or how wide a data set is, from smallest number to biggest number. It's a very simple computation. So what you're going to do is you just do the range is the highest data value minus the lowest data value. That's it. It's a simple subtraction. All right, so looking at these two classes, to figure out what the range is, for class A, range is equal to simply the highest data value, 100, minus the lowest data value, 38, meaning the range is equal to 62. And that's it. That's all you gotta do. So then taking a look at the second class, the range here is from 89, sorry about that, down to 70. So the range here is only 19. So just by looking at that alone, I can see that class B has a lot less of a range or a lot less of a span than class A. So those test scores were all closer together than class A was. Okay, so that's finding the range. Next up is what's called standard deviation, and this is the more powerful tool that we're going to have. All right, so standard deviation is a measure of variation that determines the typical distance from the center or the mean of a data set. This is the most useful measure of variation. So there's a formula for it. The good news is you are not responsible for memorizing this formula. It is programmed into a calculator. So we're going to focus on using a calculator to get this value instead of using the formula itself. All right, but I'm going to show you what the formula is so you have an understanding of where it's coming from. And it is the square root of a big bad fraction. And that fraction is n times the summation of x squared minus, in parentheses, the summation of x, quantity squared, all divided by n times n minus 1, which seems really, really meaningless. So let's refresh our memory on what all these things mean. So n is the number of data values in the set. Okay, n is the number of data values in a set. X are the individual data values. Okay, individual data values, and the sigma symbol means find the sum of. Okay. All right, there is a second formula. This formula looks terrible, but it's actually the easier one to work with. There is a second formula that this comes from, also summation of a square root, and it's 1 over n times the sum of the data values minus the mean squared, okay? That just shows that it does, in fact, take the mean into consideration. But again, the formula I just wrote in purple is not a formula you're going to work with. Even the formula in blue is not one that you're going to be responsible for. This formula is programmed into a calculator, so what I'm going to do in the next video is I'm going to show you how do you input data into a calculator and get it to tell you this particular value. All right, so that's what's up next.